Let's do another example of finding the interval of convergence for a power series. We'll look at the power series, the sum from n equals 0 to infinity of, we'll say, x minus 2 to the n over 5 to the n with an n out front. And let's just put a minus 1 to the n out front for good measure. Okay? All right, so there's an interesting looking power series. And just to make sure we recognize the form, here this is just, we have negative 1 to the n plus 1 over n 5 to the n. That's our an part. And then we have x minus 2 to the n. So the center of our power series is c equals 2. And so when we compute our interval, 2 is going to be the middle of it, and the question is, how far does it extend from there? All right, so there were two steps to finding the interval of convergence for a power series. The first is you need to use the ratio test, and that's to find r, the radius, and then next we'll apply other tests to get the endpoints. Okay? All right, so let's try applying the ratio test. I'll write down my my bn and my bn plus 1. So negative 1 to the n plus 1 over n 5 to the n times x minus 2 to the n. And then the next term will be minus 1 to the, now I have to replace n with n plus 1, and so I'll have n plus 1, or n plus 2, over n plus 1, 5 to the n plus 1, times x minus 2 to the n plus 1. And so when we apply our ratio test, the ratio is going to be the limit as n goes to infinity of the absolute value of, and let's see, we'll have negative 1 to the n plus 2 all over n plus 1, 5 to the n plus 1, x minus 2 to the n plus 1. By the way, you may be wondering, why do I always write down bn and bn plus 1 ahead of time if I'm just going to rewrite them? Sometimes you'll find that it's easier to simplify first before you write down your entire limit. In this case, there was not really a lot of simplification we could do, but especially when you have factorials, you'll find that it is nice if you can simplify bn plus 1 before you plug it in. All right, so now we got to multiply by the reciprocal of bn. So we'll have n 5 to the n on top. And then on bottom, we'll have minus 1 to the n plus 1 and x minus 2 to the n. Okay, and a lot of things are going to cancel here. We had, let's see, for x minus 2s, we're going to have n of them on top, or n plus 1 on top and n on the bottom, so all but 1 will cancel. And the same thing would be true for the 5s. We have n on the bottom that's going to cancel with the n on the top. And for the minus 1s as well. So we'll have a minus 1 extra on top, since we had n plus 2 of them and only n plus 1 on the bottom. And at that point, we have n over n plus 1. That does not simplify yet, but I think we can still work with that. We'll have minus 1 times x minus 2 times n over 5 times n plus 1. I think we've accounted for everything there. Okay, and let's factor out all the stuff that does not have to do with n. Since that stuff's just a constant, we can pull it right out of our limit, in fact. So we'll have negative 1 times x minus 2 over 5, no n's there. And if we take an absolute value, we'll just have the absolute value of x minus 2. The minus part will go away, all over 5. All right, so I'm just factoring out a constant. And then we're left with just n over n plus 1 in absolute values. But n is positive, so we don't need the absolute values anymore. And you can easily check with L'Hopital's rule, say this is infinity over infinity, take a derivative of the top and the bottom, and you'll get just 1 over 1. So our rho is absolute value of x minus 2 over 5. Okay, so let's find our radius x minus 2 over 5 has got to be less than 1 if we were going to converge. Right? That's just applying the condition for the ratio test. And so if we rearrange, we'll have x minus 2 less than 5. And so there we go. We've got our center point, and our radius is on the other side. And we could write that on the number line. All right, so there's 2. And if I add 5 to that, I'll be up to 7. And if I subtract 5, I'll be at negative 3. And so we know that we're going to have convergence everywhere in that range. And we'll have divergence everywhere that the ratio that we computed was greater than 1. So anything above 7 or below negative 3. And then we just need to check about the endpoints. Do we get convergence at those 2 points? Okay, so we've got our radius of convergence. Our interval is almost complete. Once we can sort out the endpoints, we'll be done. And so let's check x equals 7. If we plug that into our series, we have the sum, what was it? Negative 1 to the n plus 1 times 7 minus 2 to the n. So that's plugging in our x over n times 5 to the n. And we can simplify that just a little because notice that that 7 minus 2 to the n is just 5 to the n. And so those will cancel out. And so we have negative 1 to the n plus 1 all over n. All right, and so notice that is an alternating series. And you can check that if you take the absolute value of this thing, let's call that Cn. Cn goes to 0. Right, the denominator is getting bigger, but the numerator is staying the same size. So that means that we have terms that are going to 0. It's alternating back and forth, and so by the alternating series test, we would conclude that this converges. So our 7 should be included. But if we try negative 3, our other endpoint, we'll get negative 1 to the n plus 1 times negative 3 minus 2 to the n. Well, that is just a negative 1, or negative 5 to the n, which we could write as, we could write this as negative 5 over 5 to the n, if we take into account the denominator, which is just negative 1. And so here we have negative 1 to the n. Here we have negative 1 to the n plus 1, which means we have a total of negative 1 to the 2n plus 1 over n. And we can simplify that a little bit because that's another way of writing that is we have, well, one factor of negative 1 we could pull off, and then we'll have negative 1 to the 2n left. But negative 1 to the 2n is the same thing as negative 1 squared to the n, right? If you have an even number of factors of negative 1, what's going to happen? Well, when you square negative 1, you get something positive. And so this is going to be the same thing as 1 raised to the n, which is, of course, 1. And so we're left with just negative the sum of 1 over n. And that is our harmonic series, which we've studied a bunch of times. We know that one diverges. So if we go back up to our number line, negative 3 should be excluded, whereas 7 should be included. And so our interval of convergence would be negative 3 to 7, including 7 and excluding negative 3.